5 fresh out of the plastic new photos from the James Webb Space Telescope, in addition to a new revelation that sent shock waves through the space industry, are displayed in today's film. So, stay tuned to the end of the video while we examine this finding. The James Webb Space Telescope, which was launched on December 25, 2021, has been working at full capacity since July. Just like the Hubble Space Telescope, the JWST is positioned in orbit around the Earth, allowing it to take photos free from the distortions caused by the Earth's atmosphere. Compared to Hubble's 540-kilometer orbital altitude, the JWST's distance of 1.5 million kilometers places it well beyond the Moon. Its light-gathering abilities extend into the infrared region of the electromagnetic spectrum, meaning it can be used to study the entire universe. Thanks to the larger mirror, state-of-the-art detectors, and other technological advancements of the JWST, interference from Earth's reflected heat is eliminated. With this capability, astronomers can study the universe in its infancy. The JWST photo of a star at its birth is regarded as the best ever. The JWST has shed light on aspects of the dark cloud L1527 and its protostar that were previously unknown, providing new insights into the process of star formation. These fiery clouds in the Taurus star-forming region are an ideal target for JWST's near-infrared camera and NARCam, as they can only be observed in infrared light. The hourglass-shaped nebula encases the protostar, and a dark line across its center represents the outer edge of the protoplanetary disk. Above and below the disk, gaps in the surrounding gas and dust are illuminated by the protostar's light. This multicolored infrared image shows cavities formed as materials are ejected from the protostar and collide with the surrounding matter, depicted by the blue and orange clouds. As the protostar expels material, layers of dust form between the JWST and the clouds, creating Webb's observed hues. The telescope noted that the cloud's ability to form new stars was inhibited by the shocks and turbulence caused by the strand of molecular hydrogen. As a result, the protostar became quite massive and powerful, absorbing a substantial amount of material from its surroundings. Despite its turbulent outward appearance, L1527 is approximately 100,000 years old. L1527 is an example of what's known as a Class 0 protostar, an earlier phase in the process of star formation. These protostars, still enveloped in a dense dust cloud and gas, have a long way to go before they can be classified as stars, determined by their age and brightness in infrared light as detected by missions like the Infrared Astronomical Satellite. Stars like L1527 are expected to generate their own energy through the nuclear fusion of hydrogen, but this has not yet occurred. Despite its generally spherical appearance, its structure is not fixed, resembling a hot, puffy ball of gas with a mass between 2.2 and 40% of that of our Sun. The second most significant picture is the one that shows the sparkling territory where stars are conceived. To what do the stars owe their reality? One of the most staggering pictures of all time, captured by the James Webb Space Telescope, has finally provided some answers. Located near the Carina Nebula, NGC 3324, is a young, star-forming region that resembles a landscape of mountains and valleys strewn with brilliant stars. These infrared images, taken by NASA's new James Webb Space Telescope, reveal areas of star formation that were previously hidden from view. The Cosmic Cliffs is a picture taken by the James Webb Space Telescope and resembles a range of rugged mountains. The highest peaks in this image are about 7 light-years above sea level, marking the edge of NGC 3324's vast, gaseous void. The enormous space appears clear because it was carved out by UV radiation and stellar winds from extremely massive, hot young stars at the center of the bubble. Above the cloud, dramatic pillars that rise above the radiant mass of gas endure the intense radiation generated by these young stars, slowly tearing away the cloud's wall. Hot, ionized gas and dust warmed by this intense radiation appear as steam rising from the celestial mountains. Additionally, the JWST reveals individual stars and stellar nurseries that were previously concealed from view. Thanks to Webb's infrared sensitivity, it can peer through the cosmic dust and detect these particles. Protostellar jets from some of these nascent stars can be seen here, The newest starbursts, marked by red spots, are located in the dark, dusty portion of the cloud. The Pillars of Creation, an iconic image initially captured by Hubble in 1995 and retaken in 2014, is another picture that the JWST has enhanced to take the third spot. NASA's specialists were astonished by the JWST's portrayal of the same cosmic structures. The fingers seen are actually gas and dust-filled columns that surround stars that have gradually developed over eons. Mid-infrared light reveals the dusty landscape of the Pillars of Creation, giving us a new perspective on an ancient landmark. The mid-infrared light captured by Webb's MIRI device has an eerie quality. Dust and stars that are not visible at these wavelengths can be detected, as the scene is obscured by interstellar dust and mid-infrared light. Instead, the sharp, glowing edges of these massive, finely sculpted pillars of gas and dust stand out. Thousands of stars have formed in this area, though many have disappeared. Young stars, still shrouded in dusty envelopes, are often difficult to see in mid-infrared light. The red disks are very young stars, while the blue stars along the outer edges of the pillars are older, having lost most of their outer layers of gas and dust. The surrounding gas and dust appear with remarkable clarity when viewed in red light. The red area at the top is where the dust is cooler and more dispersed, creating a haunting V-shape like an owl's outstretched wings. The hazier sections below indicate the densest dust regions. Due to the thick clouds of dust and gas in the interstellar medium, background galaxies are obscured from view. For scale, this shot spans an area about 6,500 light-years away in one of the densest parts of the Milky Way's disk, allowing only distant light to penetrate. The fourth image depicts a phenomenon caused by a rare type of star and its companion, both caught in a stellar orbit. Approximately 17 concentric dust rings are visible in a new photo from NASA's James Webb Space Telescope. When the two stars are close enough, the gas expelled into space by stellar winds collides, creating pressure and dust. This process resembles the rings on a tree. Every few years, the stars' orbits align again, marking the passage of time. The dust we see here represents the system's output over more than a century, captured in exquisite detail by the JWST. A faint sign is additionally displayed in the photo. The quantity of dust rings has expanded from the previous two, which could be seen by ground-based telescopes, to at least 17. The dust rings in this picture are thicker and more extensive than they appear in reality, and MIRI is the main instrument sensitive enough to investigate them. The MIRI instrument on JWST was able to detect infrared light with wavelengths beyond the scope of human vision. Since MIRI is sensitive to longer infrared wavelengths than Webb's other instruments, it can focus on colder objects like dust rings. MIRI's spectrometer also revealed the dust composition, showing that it was primarily made of particles released by a particular type of meteor. A Wolf-Rayet W star, with at least 20 times the mass of our Sun, is on its way to becoming a black hole when it completely collapses. The very heated conditions on a WR star cause it to release massive winds, pushing vast amounts of gas into space. Most of the mass of the WR star in this pair may have been lost. This phenomenon contributes to exoplanets' rising profiles. At number 5, we see an image taken by the JWST that reveals previously unseen characteristics of our atmosphere. The atmosphere of the exoplanet WSP-39b was the target of JWST's examination. Another achievement has been reached with a $10 billion telescope, the first chemical and molecular analysis of a distant planet. NASA's Hubble and Spitzer space observatories had previously shown some details of this hot planet's atmosphere, but the new JWST provides a full inventory of atoms, molecules, and even signs of active chemistry in clouds. The latest data also shows that these clouds may resemble a patchwork quilt up close. The telescope's sensitive instruments were aimed at the atmosphere of WSP-39b, hot Jupiter, or a planet the size of Saturn that orbits a star 700 light-years away in a tighter orbit than Mercury's. The results are impressive, highlighting the capability of JWST's instruments to conduct the broad array of examinations envisioned by the scientific community, including studying the atmosphere of smaller rocky planets like those in the TRAPPIST-1 system. The findings are significant because they provide the first direct evidence that chemical reactions on exoplanets can be triggered by intense stellar light. Thus, scientists have begun using computer models of photochemistry to analyze evidence that requires such physics. Future technological advances in interpreting potential signs of habitability will benefit from the resulting improvements in modeling. This planet is a great lab for exploring the effects of stellar radiation on exoplanets due to its proximity to its host star, which is over 20 times closer to its star than Mercury is to our Sun. Regarding extrasolar planets, scientists have confirmed one's existence. The first extrasolar planet detected by the James Webb Space Telescope, known as LHS 475b, is similar to Earth in terms of size. Research team leaders Kevin Stevenson and Jacob Lustig-Jaeger of the Johns Hopkins University Applied Physics Laboratory in Laurel, Maryland, conducted a thorough analysis of data from NASA's Transiting Exoplanet Survey satellite, which highlighted the planet's presence with just 2 transit observations. The team chose to observe it with JWST, and Webb's near-infrared spectrograph recorded the planet clearly and smoothly. Webb's clean data proved that this is indeed a small, rocky planet, which Stevenson found essential to emphasize. Webb is the only telescope currently in operation capable of characterizing the atmospheres of Earth-sized exoplanets by examining their transmission spectra. With this, the team aimed to determine its composition. While it appears to be a terrestrial planet roughly Earth-sized, scientists are divided on whether it indeed has an atmosphere. Even if the planet might lack an atmosphere, researchers have not ruled out the possibility of other atmospheric compositions, such as a pure carbon dioxide atmosphere. Far more precise measurements are needed. Webb's initial finding that the planet's orbit might complete in under 2 days was quickly confirmed by the researchers. The red dwarf star that LHS 475b orbits is much cooler than the Sun, and despite its close proximity to its star, scientists believe there is a chance it may still have an atmosphere. The team plans to conduct further observations and gather more spectra this summer. Which of the JWST's images is your favorite? Let us know in the comments section. Thank you for watching this video. Please give us a like and subscribe to our channel so you don't miss out on the discoveries that the James Webb Space Telescope will bring. We have another exciting video ready for you. Click on the video on your screen, and let us take you on another space adventure. See you there.